Hello. Hello. Wow, so many people. It's impressive. Okay, it's the last talk of the conference. I'm Manel Sellés, and I will talk about my experience in coming back to the monolith. Okay, about me. This is me with beer, without beer. My Twitter is Manel Sellés. I'm currently the Vice President of Engineering at Ulabox. I'm the VP of Engineering, but I would like to call me also just a backend developer. Some years ago, I passed the Symfony Expert exam, and I'm very proud of it. I'm still saying it. And I consider myself as a DDD and TDD fan. Okay, where I work? I work at Ulabox, which is a supermarket. Online supermarket, you know, like every other supermarket, but only online. What we do? When you purchase your order at our website or our app, we prepare your order, we put it in a truck, and we deliver it in the selected slot at your home. Why I'm saying this? It's because we are not only doing the web stuff, we are also in charge of all the software of the logistics. Okay, so to start with this history, we need to take back to give you some context about what kind of company is where I work and what is the size of our team. So if we go back in time, we are at 2010. It's the time Ulabox it's founded, and it started with a PrestaShop. Okay, nothing else. Okay, 1 year later, we migrated to Symfony 2. Okay, I think we are one of the first companies, at least in Spain, that were using Symfony 2 at its own main code base. And to give you some context, the team was only 3 developers. 2 of them are very known at this conference. One was Albert, which talked this morning. Another one was Ricard, who is inside. Okay, 2015. This is the year where I joined Ulabox. Okay, so I can explain with more detail everything that happened after that. Okay, what I found when I joined the company, it was all a monolith following the best Symfony practices at that moment. So everything was a bundle, everything was CRUD, create, read, update, delete, and everything from side to side was joined with Doctrine. All the entities were related. You know, it's a foreign key chaos, in special when you need to do some testing. Some parts were tested, others not. And I joined Ulabox, and I was one of the new members of the teams, and we were already around 10 members at this moment. So we knew things could have could be better than we have done at that moment. So we wanted to check what was the main tendencies of the market at that moment, and know many things to improve our delivery, our quality, and so on. So if we go to 2015, one of the main tendencies was DDD. Okay, we had a team which was built in this foundation. Okay, I knew TDD, and almost every one of my team knew TDD. So we decided to go for it. Another one, which was not so known for our team, was CQRS. And the last tendency of that year was microservices, which no one of us were knew about that, but we thought it was cool. Everyone was moving to there, so we needed to try it at least. In this talk, I will talk more than microservices in terms of distributed systems. Okay, to not get into the discussion about the size of services and so on. Okay, just distributed systems. Okay. If we go for distributed systems, we need to check which are the main advantages that were promising us when we wanted to do so. Okay, the first one is that every service can have its own SLA or uptime. Okay, one part of our system will fail at 3 a.m. and it's no problem, but if our warehouse fails at 3 a.m., it's a big problem. Okay, decoupling. This, for me, I think this was the main reason. Okay, we had everything coupled, everything, as I said, doctrine related, everything at the same code base, everything mixed. Another one was scalability. You know, you have different pieces and parts of your system distributed. You can scale up one of them without the cost of scaling the rest. Another one was the stack or the technology. We all are PHP developers, but it's always curious to know a new stack, a new technology, or maybe you have some little problem that PHP is not the best tool for it. So we wanted to give us the chance to develop some different stack or technology. And the other promise was independent teams. Because if you have separated services, every team can be dedicated to one of the services. Okay, so let's build services, no? Everything looks fine with this description. So we started. We had the monolith, and the first service was what we called PIM, Product Information Management. I think every company that has product has this context. So the next one was trucks, something to control the load of the trucks, to get count of how many boxes are in each truck. We developed the warehouse systems in a separate system. Just to be curious, it's written with event sourcing architecture, which I think is another one advantage. You can have a different architecture. We had a child of warehouse, which was all the part of reporting. We also built another system in charge of delivery in terms of creating the routes for trucks, and it's also the app where when you receive your order, you sign it as you have received. And also a recommender. Okay, that was the picture that we built. So let's recapitulate. We were at 2015, and now after all these services, okay, I want to think as if we were at 2018. We had applied DDD and CQRS to many of our systems. In fact, all the new part was written in DDD CQRS architecture. Another thing that was not so good is that we started suffering the problems of distributed systems. And just to give you some context, we were 12 developers at that moment at the company. Okay, let's go into deep in the problems. For me, there were three main problems. Deteriorating the monolith, we had some infrastructure issues, and we were changing and we were not so fast or so easy to adapt to changeability. Okay, so deteriorating the monolith. What I mean by this? We were doing our monolith worse that it was when we started all the journey to distributed systems. I mean, we had inconsistent architecture. So our monolith became a mix of different patterns with a lot of times with not much sense. In terms of only what, if the developer that adapts to the new service has gone by it has changed. But if not, it doesn't. So maybe the same entity at some points throw events, but for other actions, not. We become our monolith adapter to other services to a layer of enrichers. Enrich is a pattern, for those who don't know, to give a local event that has thrown my system and add some info that only has my system to be consumed by the other system. We built a lot of anti-corruption layers, and even we had to do some patches to adapt to the new service, some ugly patches. In terms of infrastructure, the main problem became the project maintainability. We did a service, and as our team size is not so big, that service, once it's finished, maybe it can become 1 year or 2 without anybody touching it. So when you came again to touch the code, you said, wow, it's Symfony version like 1 or 2 older that we are currently developing at this moment. Or what about the PHP version? What about the libraries? Adding a new project became a nightmare. You needed to do everything by hand. So we didn't build anything to automate that. Backfinding became another nightmare. You had one fail at that point of the system, of your whole system, but you don't know which of the jumps was the cause of the reason of the fail. Local environment. When we only had the monolith, we were in a background local environment. So when we started building services, we tried to build a background machine for every one of them. No development laptop support that. So we need to migrate to Docker, at least in the local environment, to be able to reproduce all of our complex ecosystem in local environment. And authentication and authorization. We did not build a centralized system for authorization and authentication. So when a service needed some kind of authentication and authorization, we develop it in different ways for every service. Maybe we develop another authentication service, another authentication layer for one service. Other one was an adaptation with mapping some roles. So no same structure. And changeability, in terms of, we felt like the development was slower. When you had one field at one project, and that field, one service is in charge of creating the data of one entity, but that entity data is also consumed at the other part of the system. You need to develop the entity creation to adapt that new field and do the code to propagate it against any jump you need to make it arrive to the final. Cross-service feature became so difficult because you only, when you had this, you need to touch more than one service at a time. And the fine boundaries before the code, it's sometimes very difficult. So I think we didn't do it very well. Testing, for unit testing, it doesn't change anything. But when you want to some functional testing or some feature complex testing, it was not possible because they were separated. So we have to go against contract testing, which is a good practice, but it's not so easy. And another mistake we did was trying to build systems or services which were very different one from each other, but at some point we wanted them to be a little bit similar. Okay, so we started reusing code, and that was a bad decision. So if we go again for the advantages that I said before, and we apply them to my use case, the SLA was only for warehouse. So if we have green, orange, and red, it's orange. It was an advantage, but not so good advantage. Decoupling. Okay, we decouple, yeah, but the hard way, by putting physical limits between our boundaries. So we cannot directly connect things. So for me, it was not an advantage. It was making our lives less easier. Scalability. Okay, let's be realistic. We have not that much traffic, so it wasn't a problem for us. So no. Stack technology. You have seen a lot of services that we did. Only one was written in another language, which was Python, the recommender. So it was an advantage, maybe. Independent teams. We were 10 or 12 in the transition of that years. So how many teams can you do with 10 developers? So it was not an advantage for us. So if I'm critical with our decisions, what I think we take advantage of separating services. The main was greenfield code base. You don't need to go to the all monolith with a lot of legacy. You are a developer with a greenfield code base, a new service. You can do everything you want the way you want to do, and okay, that was an advantage, at least in the developer point of view. The CI/CD pipeline time. Our pipeline of the monolith became too large. So if you work in only one service with a smaller code base, your pipeline of the CI/CD can become shorter. So it was another advantage. And as you have different repositories, your IDA cannot make Alt-Enter included. It's physical limit. So it was okay for us. And this is very self-complacency. Okay, so was service separation a good decision for us? I will not answer at this moment. So I did a talk some years ago, with this slide, and I want to focus on one sentences I did. I really believe on that sentences 2 years ago when I did that, is that we need to build the new service independent of other systems of Ulabox, because our system is complex. Nowadays, I don't think that. Our ecosystem is complex, but it does not need to be independent, or at least not independent in terms of physically independent. So I came to the idea of the fight against essential complexity and accidental complexity. Okay, essential complexity is the complexity that a problem has by itself, and accidental complexity is something that you add when you make a bad decision. You make it more complex by accident. So after all of that thoughts, we believe that we have a new model that worked for us. So I'm going to show you the way we are developing now and what is our proposal. So if we have at one side the monolith, everything at the same place, but with no distinction inside, and in the other side, the new architecture of microservices, which one system built in a lot of separated components called services. I propose modules, which is a mix of both. In terms of, I have my system, but it's at the same place, and I can have the benefits of monolith, which everything is at the same side, and the benefit of microservices, because I have everything separated in context. So, which are the advantages of that? Sorry. If we talk about modules, they must be self-contained. They must have their own structure. That gives us the freedom to decide every module inside of system which architecture we would like to have. It has its own config. It's not so easy, but it could be moved to an independent infrastructure if we had some SLA or scalability problem. It's only accessible to the rest of the system by something I call by its API. It's a bunch of public methods that expose our module, but nothing else of the rest of the module can be read from outside. And, very important, it has no user interface. So, to give you an example of one of our part of our system, we have the module customers, another one called sales, procurement, and delivery, and another one. So we find a layer where I built every module which is API. And this is connected to the user interface of my system. That user interface can be a public HTTP API, can be a private HTTP API, or can be CLI or Workers. So, my proposal, I show you an image of our repository, and as you can see, we have an API with the app PHP, which I think everyone here is familiar, which is our front controller. So this is very similar as any other Symfony application. What differs in source code, we have our all bundles and our new components, new modules. Okay, you can see that the same that we saw at the past side: customer sales procurement, customer sales procurement. Okay. Okay, if we go inside a bundle, our code base is too large. We have not been able at this moment to migrate everything. So we cannot migrate everything in one shot. We need to do it progressively. So we still have some API bundle. But we have done is reorganize something. So we have an infrastructure part when we can define the UI or some configuration of the framework. Then we have the resources with the routing and services for the HTTP part and the testing. And if we go inside the structure of a module, for instance, the procurement module, we have a replicated directory structure of a DDD application, but inside of each module. For instance, we have the application, which isn't shown, but you know how it works. The domain, which contains all the aggregates that belongs to our module. We also have the infrastructure with the concrete implementations in technology, in concrete technology of our module. We have some tests, mainly integration and unit. And this came the different part. It's something I call interfaces, and it's where I put my API, which is not so complicated. It's just a list of methods that make my module public. So we are in the middle of this transformation. So our current status, if we go to the current year, is that we are in the middle of the migration to what I like to call my modular monolith, which is something, it's a better word than that monolith legacy. I think, and the results say that, we have improved our delivery in terms of quality and speed. And to give you some context, we are still 10 developers. So if you remember the slide about my services, we have transformed it. Okay, we removed tracks. We have removed the recommender. We have integrated PIM inside the monolith. We have integrated the delivery service inside the monolith. And we have integrated the child of the warehouse inside warehouse. So if we look at the current overview of our system, we have our modular monolith, which has our customers module with sales module, procurement, PIM, delivery, and other modules that are not shown for size purpose. And we still have our core bundle. I think everybody has its core bundle as a system. We have our API bundle, which is on before, and we still have payment bundle, and our system is still distributed, but not so much, because we still have the warehouse management system separated from the monolith, which is warehouse and its logistics. So, conclusions. Distributed systems and microservices didn't work well for us because you need to have some prerequisites in terms of going against going for that change. One of them is automation. We did no automation for every new service that we had. We didn't build an out system to centralize the authentication of our platform. All the reporting was made from the monolith. So at least some of the services became useless because all the information that they had finally needs to go again to the monolith. Because in terms of reporting, We needed, all the reporting and all the integrations were from the monolith. So the monolith still has all the data. And another question that I made to myself is how to separate. I think we didn't separate well, but has anybody separated well when you are building some different modules, some different contexts, some different services? So which will be the best separation? We will need to separate in business units or in development units. Technology. You need to think if in your company you are using technology as a tool or as a goal. Decoupling. Decoupling was one of the most important things for us, but we decoupled, but with physical limits, which I think was a wrong decision because it made it harder to us. And the big conclusion is that kind of architecture was not for our team size. I think, or I hope, many of you of the audience can feel the same, in your case, the same that I'm explaining. And remember, legacy code must be fighted. So thank you, everybody.
No. Bueno, ara després sí. Okay, guys, this is unacceptable. So from the organization, we decided to not take any questions. And next time, please, since you are breaking the code of conduct, please respect the speakers. I'm sure Manel will be able to answer all your questions, but we had to close the questions application. So yeah, think twice about these things because these people take lots of effort and it's not fun at all. Sorry, guys.